All right, guys, let's start off here on number 1. So we're just going to do some review to start, and we're going to learn our new stuff. So the review, to switch it to exponential forms, remember the base of the log becomes the base of the exponent and gets a new partner. So that's going to be the negative 2 power, and then that's going to equal 1 over 9. So whatever was inside the log is now isolated. All right, next up, number 3. So for this one, remember, we're going to go switch it into logarithmic form now. So in logarithmic form, remember, again, we're going to write the word log, and then the base becomes the base. This one's a base 10. So remember, base 10 is always the invisible base, so I'm not going to write base 10. It's assumed it's a base 10 in there, or in the base, and then inside the log is the new partner, so that's 81. And then that's going to equal b. So whatever was in the exponent is now isolated. So that's really important. Whenever you have the no base written on a log, it's assumed it's a base 10. All right, next up, we're going to evaluate these expressions. So we have log base 4 of 64. So I'm going to set that equal to x. And then we will switch it to the exponential form. So I'm going to say 4 to the power of x equals 64. So the base becomes the base, and it gets a new partner. And then I need to think about what power turns 4 into 64. So 4 times 4 is 16, and then 4 times 16 is 64. So that would be the third power. All right, next up we have number 7. So I'll set that equal to x. And then let's see, what do we got here? So we're going to go 3 to the power of x equals 1 over 27. I already know, since we have a denominator there, that this is going to be a negative exponent. And so I know x will be negative something. And then I know that the third power turns 3 into 27. So the third power turns it into 27, and then the negative drops it down at the bottom. All right, now we're going to expand each logarithm. So this one, remember that every kind of thing inside of here gets its own log, and anything from the numerator is positive, anything from the denominator is negative. So I'm going to say log base 4 of x to the 5th. So that gets its own log. And then plus log base 4 of z to the 5th gets its own log as well. And then minus log base 4 of y to the 15th. So everybody gets their own log, but since the y to the 15th came from the bottom, it goes in a negative log. All right, so the next up, we move all the exponents out to the front, like that. So that'll be 5 times log base 4 of x, and then plus 5 times log base 4 of z, and then minus 15, since that one's a 15, log base 4 of y. So 2 steps on those ones. All right, number 11 and 12, you can still use kind of the same rule, but just remember that if there is no denominator, that means that everything's in the numerator, so everything is going to end up in a positive log. So just think of it like that. There's really just nothing in the denominator, and so I'm going to say log base 8 of x plus log base 8 of y to the 4th, and remember that 4th power only applies to the y, not the x, and then plus log base 8 of z to the 3rd. And then, like we did on the last one, we're going to go ahead and move all the exponents out to the front. Now, the first log does not have an exponent. That's fine. We'll just rewrite it as is. And then this one will say 4 log base 8 of y, and then plus 3 log base 8 of z. All right, so now we're going to work on our new problems, which is called condensing logs, which is really kind of just the opposite of what we were doing before. So we're going to kind of look at this as 2 steps. The first step is to move the coefficients in front to exponents inside. And so that's kind of our last step on the previous page when we're doing the expanding. So this is going to be the first step when we do these ones. So if we have something like 3 times log base, 2 of x, we're going to turn that into log base 2 of x to the 3rd. So on the previous page, we would move that 3 out to the front. Now, if you're going to have a number in front, you move it up to the exponent. Okay? And then Step 2 is going to be you're going to move everything. You're going to have kind of several different logs. So I'll just say log base 2 of, let's say, x, and then negative log base 2 of y. You're going to move that together into one log of that same base. And then the way you're going to do this is that everything that came from a positive log is going to go up in the top. Everything that came from a negative log is going to go in the bottom. So let's do some practice here. So number 13, I actually don't have any. Step 1 is done. There's no numbers out front. So we'll just move on to step 2. So I'm going to condense all of these into one log. And then in the numerator, I'm going to put everything that came from a positive log, the denominator, everything from a negative log. So that means x is on top and y is on bottom. So this is my answer. This is not part of my answer. I just like to draw it over there to kind of help me out. All right, so number 15 here. I do have exponents this time, so I'm going to move those up here. So this is going to be log base 7 of 12 to the 30th power plus log base 7 of 5 to the 6th power. And then I'm going to condense that all into one log. So log base 7 of, and these are both coming from positive, so I'm going to put them both in the numerator. And since I'm doing that, I really don't have a denominator in this case, so I'm not going to put a denominator since both of those are positive. All right, lastly here, number 17, I'm going to move these. Let me do this in pink here. So we'll move these coefficients up there. So it'll be log base 6 of z plus log base 6 of x squared minus log base 6 of y to the third. And then we'll condense this all into one log, base 6. And then we do have some positives and negatives here. So positive, we have a z, and we have x squared. And then on the from the negative is y to the third, so that goes on the bottom. And that's it.